Welcome to Programming from Scratch. Today we're going to talk about JavaScript equality. By equality, I mean checking if one thing is the same as another thing. In most languages, there's only one way to check equality, and that is using a double equal symbol. The equal symbol is right next to the backspace, and it's on the same key as the addition or plus symbol. So the way that we use this is we can say 1 is equal to 1, just like that, and it is true because 1 is equal to 1. And it works the same for strings. See? However, if we said 1 is equal to 2, then it's false. All right. So JavaScript does something a little different with its double equal symbol, and that is that I can check and see if 1 is equal to the string 1, and it will say that it is. Also, if I were to check and see if 1 is equal to true, well, that's true, and 1 is equal to true, that's true, and hello is equal to true, well, that's false. Okay. Why is 1 string, and if I say 0 is equal to false, well, that's true, and hello is equal to false, well, that's false. Right. So what JavaScript is doing here is it's doing something called coercion. It takes the string 1 and it converts it into a 1, and it takes the true and it converts it into a 1, because deep in the core of the computer, true is represented by a 1 and false is represented by a 0. So it takes those two things and it tries to make them into the same type of thing, and then it checks to see if those same type of things are the same. And of course, 1 is the same as 1, right? The reason it does this is because if you have a text box and you type in a value, that value is a string, but you may need to compare that value to a number or to something else, and so JavaScript's just trying to help you out. There's a lot of things in JavaScript where it just tries to help you out. Sometimes you don't always want that. So a way to prevent that from happening is we can say 1 is triple equal to 1, and then we get false. So the triple equals actually prevents all coercion. It only checks if the thing is exactly equal to the thing. Strings, numbers, and constants are actually all constants in the system. If you were to look at the code after the computer's done doing whatever it does to it, then you would see that there is actually a value for this string, a value for that 1, and a value for true that says it's equal to 1. There's only one of those values in the whole system. If I have the string hello and I'm using it somewhere in my program, and then later I have the string hello again, I'm only actually using the same string hello. It's not a new string. The system, when it figures everything out, is smart enough to make sure that there's only one of those. So when I compare hello to hello, and let's do it with a triple equals, you see that it's true. That's not the same result you'll get for all things. For instance, an array, right, which is just a collection. For instance, 1, 2, 3. There we go. That's an array. It's a collection that has the values 1, 2, and 3. But an array with no values in it is not equal to an array with no values in it. And it's also not triple equal to an array with 0 values in it. You get the same result, sort of, if you do this with a JavaScript object. We'll cover those later. We'll cover arrays more later also. But for a JavaScript object, it actually blows up. So the only way that we can actually make this comparison is if we create a variable, which we will cover more later. For now, just assume that A is equal to that value, and B is equal to the object, the two curly braces. And so now if I say A equal B, then I get false. The reason is because these are what's called reference values. So there's actually a chunk of memory on the computer that value is stored into. And when you compare them, you're actually comparing if the chunk of memory is the same chunk of memory, which you're actually doing for the constants. Remember the yay, the constants 1, string 1, and true. You're doing the same exact thing, except for, like I said, there's only one of those. So of course, the chunk of memory is the same chunk of memory. Let me clear this out. If we did the same thing, do I still have that value? I do, okay. If we did the same thing and we compared A to A, because they're in the same chunk of memory, we get true. And that's really all there is for equality. The double equals will try to convert the values so that they're the same thing and then compare them. The triple equals will only compare if they are exactly the same thing, meaning that they occupy the same space in memory on the computer. And my suggestion, boom, my suggestion would be to always use the triple equals unless that's not working and you know why it's not working. This will prevent issues with all of your calculations. You could write a program using just double equals, but eventually something's going to be equal that you didn't want to be equal. Like I showed before, 0 is equal to false, and 1 is equal to true, and 1 is equal to true, and true is equal to 1. No, it's not. Sorry. But see, stuff like that. You think something is going to be equal and it's not equal. So just always use the triple equals and you won't have that problem. If they're not exactly the same, it will be false and you will get the result that you expect. You can then change it to a double equals when you're not getting the result you expect because you're doing a representative comparison as opposed to a strict comparison. Okay, thank you for watching. That's all there is today. Leave a like if you liked the video, leave a comment, leave a dislike if you didn't like the video. If you leave a dislike, please leave a comment. I want to know what I can do to improve the videos. Again, thank you for watching, and stay tuned for more videos coming up soon.